Testing just units doesn't give you an entire confidence that your system is going to work. You need to make sure that the units are working together. So your scope kind of increases as you go up the pyramid, but so does your confidence in the test results. Anand also talked about this ice cream cone pattern, which is again very typical that we've seen in organizations that we have consulted in, where this emphasis or focus on automation tends to become more of a QA responsibility, a QA accountability, and QAs are definitely not involved at a unit level or code level. They're typically involved at a system level. So that automation ends up leading to a lot of UI tests, making the pyramid very top heavy, leading to an ice cream cone. But remember, the UI tests come with a lot of cost. So again, something that Anand talked about, the test automation could actually be a devil in disguise in such cases. And that definitely leads to dilemmas, which we'll be going to in a little more detail. So what I'd like to do now though is first talk a little bit about what we are trying to do when we are doing agile testing. There are multiple principles that we want to adhere to. One of the most important being moving testing upstream. We want to reduce the cost of defects, right? And the only solution is to move that upstream. You cannot wait for the tower of Pisa to be completely built and then figure out that it's going to lean. That's just too late, right? And there are again multiple practices that can help you achieve this principle to varying degrees, of course. Anand had a very simple one again, test automation. Here there's a slight breakup. And definitely we've realized that manual testing has its own place as well. It sits at the top of the pyramid, if you remember. And we will talk about feedback as well. For the scope of this discussion though, I'll keep TDD out of it and focus more on the rest. Let's start with ATDD. So TDD, as you may have heard, is test-driven development. It essentially means that you write a unit test before you write the code which will make the unit test pass. So your test will actually give you a red result of failure. So then the developer will subsequently write code which will make that small scenario implemented. And now if you run the same unit test, it will go green because it has been implemented. And you do a lot of cycles at these. And remember, this is at a class method level, not really at a system level at all. This is done at a very, very small level. We are talking about classes and methods here. ATDD is a variation of that perspective. It's about acceptance test driven development. And acceptance tests are more business facing than unit tests. These can be at a service level, an integration level, but more likely they are at a UI level, at the functionality level, not just a component level. And this is where QAs can get involved equally as the developers, right? That's gonna be definitely in the scope of this discussion. But it's not easy. You'll quickly see a list of problems that we have seen at least on the ground. That's a long list. First one is that remember ATDD is still going to happen in parallel to development. So it's not about critiquing the product, it's about supporting programming, doing it while the implementation is happening. That definitely needs a lot of close collaboration with developers, and remember as well that it's business facing, so not just developers but also business analysts, perhaps even the business stakeholders. And of course we talked about the ice cream cone. You want to be careful of that because whatever functional tests you're writing at a system level will lead to slow tests, and this will grow, so your test suite will get slower and slower over time. Maintaining that test suite is more difficult. You need test data. Again, you cannot simulate test data at a unit level as easily as a unit level because you're talking about system level data. So not just one table in the database, but multiple tables in the database. Perhaps a few web service calls as well. So all that sort of test data has to be present for ATDD to work. And flaky tests. You launch an automated test. It opens the browser. In the browser, a web page makes an AJAX call. Turns out the server on which that AJAX call is going to run has some performance issues, certainly. It's running a huge query, right? Now your AJAX response is not coming back in time. Your test waits for a little while, but then it fails. But is it that there's actually a defect in the product? Maybe or maybe not. So maybe if you run this again, but now the SQL query has ended, and now your server is suddenly very much more performant, the same test will now pass, because the AJAX call will come back in time, right? And that's just one example of a flaky test. There are different examples as well. We'll get into more details there. But let's start at some proposals of a solution to the collaboration bit. Something that we implement in every team is a story kickoff. It just sounds fancier than what it is. This is just about a developer is ready to pick up a user story for implementation, right? At that point itself, the business analyst, the developer, and the QA come together on one desk, which could be the developer's machine or the business analyst machine. They go through the story requirements. The business analyst explains the requirements in crisp terms to the developer as well as the tester. If there are any questions around the story, more details that you need, some questions which are not answered, you ask them right there and get those answered. And once all these roles have a common understanding, is only when you proceed with the implementation. So the developers will start with the implementation of the feature, while the testers are preparing your test scenarios, and possibly even the automation that goes along with it. So just having the small placeholder meetup for every story that you do. Again, it's not about clubbing stories and doing it together with the entire team. It's for every story that gets picked up. That helps a lot with the collaboration. I would say it is a little challenging if the testers are not sitting together, but we still managed to do that with some of our testers working from home. So if they are still available online, there are tools today where you can do a screen share easily, and you can still talk through with the distributed people being present together. If time zone is an issue, then definitely this will be more difficult to do. But location itself is no longer an issue. Second bit is again about collaboration. So a tester will not wait till the feature is completed to come up with the scenarios. So we're talking about design scenarios perhaps even before development. So that scenarios that you are talking about, you have identified, is like an input to the developers as well. Because you'll have acceptance criteria which is at a business level, calling out what the feature needs to do. But you need to tell your developers about the edge cases, the various scenarios which are too detailed to be mentioned at a business level. So the developer is taking care of them as and when he or she is implementing the code. So again, that's a practice which is important. Definition of done. When is a story done? When can a developer claim that I've finished implementing this feature, I'll move on to another feature or another story? Your definition of done should include that there are no defects on the story. So some basic tests have to be done against it. Remember, more of your elaborate testing should be moved to automation. So those automated tests should all be passing. It's only then can you claim points about having a story done. You showcase a story to the client only when it is done. Done being there are no defects that any of you in the team found, whether developers or testers. And that leads to more collaboration, because everyone has the common goal that story should be done in the iteration. There is no stabilization phase. Some variations of the agile methodology like to keep aside 1 week or 2 weeks for a stabilization phase, also called hardening in some methodologies. That we've seen leads to bad behavior, because then the focus on quality gets deferred. Oh, let's get these stories done. We anyways have this hardening phase per iteration. An iteration or sprint could be for about 4 weeks, right? So you keep maybe the last week for this stabilization phase. And it's only then that you realize that a lot of defects had actually crept in. But then it's too late, because you're nearing the end of the iteration. You either work late, work over weekend to make sure your commitment to the iteration is fulfilled, or you have spillover. where your story is not actually called completed in the iteration and it moves on to the next. So why defer testing to that phase, right? So it's again a symptom of waterfallish tendencies still existing in an agile implementation. Coming to slow tests. So again, we'll refer back to the pyramid. Remember that the tests at the lower half of the pyramid are really, really fast. I could execute thousands of unit tests in about 2 or 3 seconds, just 2 or 3 seconds. Whether it's a Java platform, Ruby platform, .NET platform, unit tests are really, really fast. Which means what? That you need to focus on getting that pyramid right. So as testers, you need to make sure which tests are being covered at the unit test, which tests are more important to be covered at a little higher level in the pyramid, which is the functional test and the service level test. If you do realize that certain scenarios are not being covered at the unit test, and you feel they don't really impact the business flow, the end user flow too much, there are edge cases, let's say password validation, right? Whether I have an ampersand in it or whether it's incorrect length. All those various variations of the password policy does not have to be tested at a UI level. It's not going to affect your feature flow or end user flow. At that level, you just care, do I catch an invalid password or do I move on with a valid password? The definition, the various definitions of an invalid password should be covered at a unit level, right? So just take care of that. That said, in a complex project, at a UI level, you'll still have enough flows which are justified to be there, but they still cause slowness. And that's where you can look at parallelizing those tests. Earlier, we tried this about 5 years back. It was difficult to do. But today, there are tools which make it so much easier, where you have multiple automated test scenarios written. All you have to do is run them on parallel processes. If you have more hardware, you could run them on multiple hardware as well. And your test runtime will come down drastically. Some of the challenges even in that implementation is to make sure that there's enough isolation in terms of your database or web service calls, any common data source. So make sure that you're using different users for the parallel flows, or perhaps different databases, right? Because you don't want one flow to affect data which is being used in the other flow. And of course, another challenge is to make sure that you consolidate the results from all these parallel executions and come up with one final report. Again, remember, a single dashboard is important so that you get a quick visual feedback. And of course, a technique very commonly employed now is headless browser testing. So there are a few flows which you know do not involve a lot of browser-specific implementations, right? Maybe there isn't a lot of JavaScript. JavaScript has a tendency of working on one browser and working differently on other browser. But for simple cases, let's say that's not an issue. Then you do not really need to launch Firefox in the screen and then run through. Firefox has a way where you can run it in a headless mode, so it doesn't actually launch on the screen. There are other browser implementations like Phantom.js, which do not launch at all. They'll just simulate browser behavior. And those again make your tests much, much faster, even at a UI level. Moving on to test maintenance, again, pyramid. Maintaining unit tests is much, much easier than maintaining tests which are written at system level. Why? Because let's say a code or a method changes, the developer will fix the corresponding unit test of that class or method. And there's almost a one-to-one mapping of these unit tests and the code under test. If such a code changes, but it indirectly impacts things at the flow level, right? So let's say the flow test will then fail because it did have an impact, and let's say it's a good test, so it does fail. Tracing back down what exactly went wrong in that flow back to that one small method is gonna be a tedious task, right? So again, maintenance is difficult for such tests. You'll have to see whether it failed because of flakiness, was it just that an AJAX call was slow, or was it because the system under test was actually faulty? If yes, then you have to triage what's happening in that system. Is it this layer, this layer, this layer, or is it the last layer? or it could just be incorrect data, right? So again, following the pyramid helps there. Other aspects is again, managing that you have too many tests, the volume of tests. Try to consolidate those. Find out duplication across your tests, or if there'll be a tendency, which is not a bad tendency, to add even UI level tests per story. Because in an agile team, everyone is working on at a story level, right? So even your testers are going to test per story. But at that said, while you get feedback of the story, in the next iteration, let's say in the current iteration you find out defects in the story based on your automation, then great, right? And someone fixes it. Now you're all green, and you say that in the iteration we completed these stories. In the next iteration, if a test fails because of regression, some other code change caused the previous story to fail. In the next iteration or subsequent ones, it's not that interesting to figure out which story actually failed. Because that story is done with. The team is done, we claimed points for it. Some other story impacted and broke an earlier feature, and earlier feature doesn't matter so much. What matters is that this feature is broken, this flow is broken, I don't care which story I trace it back to. So again, remember that at the end of every iteration, or maybe at least a couple of iterations, take time out to merge these story level tests into a flow level test. Reduce the number of independent tests that you have, right? Because whether a user can log in is probably immaterial after a few months. What the user can do after logging in